and I'll introduce myself in a quick second. And actually, I may or may not introduce myself depending on how it goes, right? If it comes out, then no way. All right, so the first thing that you would see is that the title is a little different from what you saw on the website, right? If you came expecting that it is going to be Netflix Zoom, I'm really sorry. It got lost in translation at some point, right? But this is close. This is pretty close to Netflix Zoom, so I'll be touching on Netflix Zoom quite a bit, and then sort of go into this new product called Spring Cloud Gateway to show how it is so much more better than Netflix Zoom, right? So again, before I start, how many of you guys have worked on Netflix Zoom before? Nobody. What? Netflix Zoom? Nope. We gotta be in trouble today. What about Spring Cloud? Ever heard of Spring Cloud? Worked on Spring Cloud? Awesome. All right. Good enough. All right. Spring Boot? Yes. Oh, my goodness. Thank God. Because I've actually made too many assumptions about what people know, and I think those are going to be wrong. But we'll see as we go along. If you have any questions, just ask me right there. Because, again, like I said, I've made a lot of assumptions right there. Right? Okay, so the presentation is about Spring Cloud Gateway, and just to set the context about what gateways are, right? So I'll cover my name a little later. Okay, but just one quick caveat that if you Google around for Spring Cloud Gateway, you might reach this presentation, and you might be surprised by the similarity between this presentation and the presentation. That is because I have copied this. Right? So that's a caveat. It's not plagiarized by any means. I've actually asked the author that I'll be borrowing this, right? Okay, so what exactly is a gateway? So what I thought was I just put in the most common topology of the gateway. So if you have a bunch of microservices in your organization, you would typically put a gateway on top of it for your end users, right? So for your consumers, you would typically provide a gateway. And the reason is you want one endpoint for your users, but you don't want a lot of endpoints. Right? So that is typically why you would put a gateway. What is the use of it, right? In single word is for control, right? Because all the requests are going through this one gateway component, you have a lot of control, right? And what can you do with that control? You can do things like, first of all, something cross-current, security, right? Security monitoring. If you want to limit the number of requests that are going to your microservices, you can do it right at the beginning. Right? One of one that I have used in the past is for canary deployment, where if you have a new version of a software, you can sort of through the gateway, you can send a limited amount of traffic to that new component, and then over time ramp up traffic. Right? So that is canary. One more. I'm part of Pivotal, and we do a lot of application transformation. So one use case that we extensively use it on the field is for legacy to monolith migration, where say if we encounter a legacy system at a client application, what we do is the very first thing that we do is just put a gateway on top, right? And then so we slowly carve out microservices and direct traffic to them. If it looks good, you continue with those microservices, and hopefully over time you carve out enough that the monolith itself can be strung, right? So that's a use case of a gateway that I have used in the past. Any questions so far? Any questions, concerns? No? All right. Gateway types, right? So you may have encountered a bunch of them in your own fields. It can be an appliance like F5, FPG, CAPI gateway. It can be a SaaS-based software like FPG API, or AWS ELB is a stretch, but it can also be considered a gateway. Web servers. Some of the web servers are now implementing gateway-like content. Nginx is one. Apache, Mod Proxy is another. On the Kubernetes side, how many of you work on Kubernetes? All right. So on the Kubernetes side, there are these service meshes, which are not really gateways. What they do is more microservice to microservice. So they enable what is called as east-west transaction rather than north-south, which is from the customer down, right? So it's not exactly that, but again, it fits in a little, right? The focus of this presentation would be the software-based gateways. And there are three that I am aware of in this space. One is the Netflix Zoo that I just mentioned, Spring Cloud Gateway, which is what I've been presenting here, and something called Ambassador, again on the Kubernetes side. Right? So those are the software gateways that I'm aware of. All right. So if you have used Zool before, Zool has a few problems. So Netflix, until say about 3 years back, used to use Zool extensively for their gateway functionality. Right? So any request, say from your Netflix device, say Roku, or if you access Netflix over the web, it always goes through. It always used to go through the Zool layer. Very recently, they migrated from Zool to a newer version of Zool called Zool 2. Unfortunately, they decided not to open source it, so it's not available in the open source way, right? So at some point they may open source it, but at least up to this point they haven't open sourced it, right? So people who are using the Netflix stack are stuck with Zool 1, right? And there are a bunch of problems with it. First of all, it is servlet-based. It is raw J2E servlet-based. It implements something called a blocking API, and we'll quickly cover that part. And thirdly, it's not different. If you're doing a pretty simple thing like routing, it is good for that. But say if you want to do something a little more extensive, add more security or do something a little more extensive, then you have to explicitly write a filter, and writing filters for Netflix Zool is not that easy. I know some of you may I can see a little bit of reaction on your face, but right. So have you used Zool? No. Okay. All right. So if that is the case, nobody will contest this, right? All right. Just to quickly cover what async and non-blocking mean. So this is an example of a blocking IO call where your thread is processing something. At some point, it makes an IO call, and at that point, your entire thread is blocked, right? It's not doing anything, it's just lying on there until your IO returns, right? So this is an example of a blocking API call. The catch with this is that, say, if there are 300 requests coming in simultaneously, very likely all those 300 threads are blocked, right? So you're creating a lot of threads, which is sort of a very costly resource for a Java-based, for a JVM, right? So that is the problem with Zool. It uses blocking calls for the downstream microservice calls, right? So now it can be improved a little by making the blocking call itself async, which is that at the point when you are doing the IO call, you hand it over to a thread pool, right? So what that means is that the main thread which is processing the call continues. It's not blocked at all. But then you're still blocking some thread within the thread, right? So this is an example of an async blocking. What is the best is the non-blocking IO call, which is using Java's NIO libraries and using OS level features to make this IO call from a system to another system. Right? And what happens there is that if a thread makes a non-blocking call, it is never blocked. It just continues forward. But then you can imagine that something still has to block, something still has to pull that connection to find out whether the transaction is done or not, right? And there are frameworks like Neri. What they do is they put an event loop which sort of keeps polling the open connection. It's not called a connection, it's called a channel. So it keeps polling the channel to see if the transaction is complete. And if it is complete, what's typically done to the application side is they register a callback. And once it is done, your callback gets called. Right? So this is an example of a non-blocking event. Any observations, concerns? No. All right. So this is, if you use non-blocking code for a system like a gateway, it is the best thing to do because you are not going to use too many threads. The event loop doesn't require too many threads. You say even for Neri can typically handle something like tens of thousands of connections with say something like 10 threads, right? So you are being very, very efficient with using it. Right? But the problem with non-blocking IO is that coding is pretty difficult. Right? So if you have done any Node.js coding or anything else with callbacks, you reach a stage called the callback hell, where you have callbacks within a callback within a callback, right? So it makes coding super difficult, and even more than coding, if there are say stack traces, you will not be able to make out what's happening from the stack trace at all of a callback, right? Because it will be so messed up. It won't trace back to the line where you have where you have defined the callback at all. It will be some framework-specific stack trace, right? So even more than the callback hell, it is super difficult to debug in case of issues in production, right? So a solution for that is to use something called the reactor types. How many of you have heard of RxJava or Rx? Oh, awesome. You must have used it in IT. I used to be a former IT employee, that's why I knew that stack very well. RxJava 2. Okay. So even on the Android side, a bunch of you may have used RxJava, right? And there is a RxJS, which is pretty equivalent. So if you do JavaScript coding, you may be familiar with the React type on the JavaScript side. On the Spring side, there is now a specification called the reactive stream specification, which has formalized, which has sort of converted RxJava into a proper JVM standard actually. And I believe it was released as part of the Java 9 release, right? But on the Spring side, there is a library called Spring Reactor, which implements the reactive stream specification. But it looks more or less the same. So the way things would work there is everything is treated as a stream, right? So you don't have to really use callbacks to react to something. What you do is you use the operators which RxJava or Spring Reactor provides to act on it, right? So I have a quick demo that I'll show you how it works. It may get a little confusing, but let's see. So this is an example. Is this clear? All right. So this is an example of a callback here where I am making a service. I'm making a call for something called a list of cities. So let me show you in a slightly different way. This is a Spring Boot application, by the way, and written in Kotlin, right? So, all right. So this application exposes two endpoints. The first endpoint is where so the first endpoint is, so I'm using like something similar to curl. It's called HTTP. It's like a developer friendly. Right? So this application exposes one endpoint called city IDs. So given if I ask for city IDs, it gives a list of IDs. Right? So here, and then if I ask for the details of a city, right? So if I say get the details of say city with an ID of 7, it gets me the details. It says ID of 7 will see that, right? You guys can imagine what city with ID number 1 will be, right? Nope. It is Portland, of course, right? So if I ask for city number 1, it is Portland, right? Okay, so now what I want to do in my sample application is get the list of cities, get the list of city ID, and for each of them get the detail of the city and then put it together. Right? If I were to use a callback-based approach, it looks something like this, where, by the way, I'm using a library called New, which is a small wrapper over called the raw material is pretty good. So this is a sort of a small wrapper library which makes very coding a little easy. Right? So what I'm doing here is first I'm making the call for CPI, right? And then I'm attaching so it returns a type of listenable feature. I'm attaching a callback to that. So this is the way that Ning allows a callback to do. So I'm saying I a listener, and this is the callback functionality where I get the body, and from the body I get a list of norms, which is all the city IDs, right? And then for each of them, again, I'm making a downstream call to the city. Right? So now I have the first original call, which returns 7 cities, and then 7 child calls, right? And each of them, again, I'm attaching a callback. Right? So again, I'm attaching a callback to each of them. So now you can see there's a callback within a callback, right? So, and it is sort of super difficult. So even sort of coding it was very painful. Right? You can see, I think after writing it once, I doubt anybody can figure it out. So it is pretty difficult to debug. Right. So this is an example of a callback. Just to sort of run it, just to show that it actually works. you would see that it's in the list of signals. Right? And it is out of sequence because again it is a sequence code. Right? It's using an IO code, and you see that it's using a different. So this is a different ID, head ID. You can see that it's using different head IDs. Right? So it does its job, but it's pretty difficult to do. Right? A slight improvement on that is something called completable future. If you have worked with completable future in Java, this is a little bit better than using callback. Because completable future has operators like when compose, which allows you to sort of compose the once the result is back, to compose the downstream. Right? But it doesn't have enough operators. So one bad thing is, so I'm making a call for all the downstream, so all the 7 downstream cities. Right? You compose them together into a single list of cities. I'm using this all of operator. And unfortunately, all our operator returns a null, right? So you have to do something crazy to actually put it together with registers. Right? So again, don't even bother with this code, but just know that it is, although it is definitely better than a callback, but it's still not that good, right? And just to again run this code. It returns a list of cities. For whatever reason, it is not out of sequence. I have no clue why. I'm not really about it, but this is also right. So that is one catch which we have thought of go through. But a better one, a really better one, is using something like RxJava. Right? Using RxJava, but I'm using a library called Spring Reactor. You see that I have the types called reactor.co.publisher.flights. It is like RxJava's observer. Right? So this makes the code super simple. So if you look at it, I'm getting the list of city IDs over here into something called a flux type, which is nothing but a folder for stream of data. Right? So in this specific instance, I'm getting a stream of city IDs 1, 2, 3, 4, 5, 6, 7. Right? Then it comes with an operator called flatmap, right? Where I do the subsequent operation, get the city detail. Right? You can see that it's so much more concise. Right? And finally, once I get the details, I have to sort of walk through my flux to get the detail out. I have to sort of walk through my stream to get the detail out, which is what I'm doing here. So somebody has to subscribe to that stream to get the details out. So that code alone is a little ugly, except that you rarely see that part of the code being in your code, because systems like Spring MVC, they handle flux type natively, right? So if you return a flux type from the controller, it is automatically converted to a list and list JSON and sent back. Right? So you would rarely see this raw code in there, right? But everything else. So the top part is sort of what you would work with, right? And you can clearly see that it's far better than the callback approach or the future. Right? It reads easy. It sort of you can immediately make out what exactly it's doing, right? And Scala background, right? So this flatmap should be super familiar to you. Oh, sorry. So flatmap should be super familiar to all the Scala, right? So. All right, so yeah, this is a quick walkthrough of what's wrong with callback, what's wrong with completable future, and where this reactive types fit, right? All right. So knowing this, the new project Spring Cloud Gateway is based on that reactive stuff, right? So it's based on something like RxJava, it's based on proper reactive stream specification, right? So the code and everything else should be sort of far easier to do. It is not based on blocking API, so it exposes a Netty server and uses a Netty client to make the downstream, right? So it is end-to-end non-blocking. It is again, if you're on the Spring side, it is based on the latest Spring, so it is based on Spring Boot 2 and Spring 5. Right? The catch is that it is not GA yet; it is still in a milestone release candidate state. Next month, it is supposed to be released, right? So in another month, this should be available for people to use in production. But right now, you can sort of play around with it. All right. So on the Spring Cloud Gateway side, this is what a gateway implementation would look like. Again, you are essentially taking calls from the consumer. The gateway is then based on something, it is routing to the different microservices. Right? Now, there are very few, and there is a Netty server that is completely and it is using the Netty client to make the downstream. Right? Okay. So now within Spring Cloud Gateway itself, there are sort of very few concepts. One is the concept of a route, which is where should it route the request, right? And this and within the route, on what basis? So when a request comes in, should a specific route handle this request, right? So that is done using something called a predicate. So if a request matches a predicate, then that route will handle it. That's all it means. And then there is a concept of filters. So if a specific route matches the request, then the filters will enhance the request, right? So add a header or apply security to it, or let's start putting a trace ID for monitoring, right? So that is what a filter is. It modifies the request in certain ways. Not just the request, it can even modify the response, right? So before it makes a downstream call, it can add headers, and on the way back, it can again add a response. Right? And not just headers, it can actually modify the body, but modifying the body is definitely not fast. If you really have to modify the body, a better thing might be to delegate it to a downstream microservice. Any questions here? All right. All that I had left was more demos, right? Okay, so let me show you what a Spring Cloud gateway code looks like. So if you want to start with Spring Cloud Gateway, have any of you heard of the Spring Initializer site by chance? Okay, awesome. All right. So Spring Initializer site allows you to get a starter project using Spring Boot, right? So if you go to the start.spring.io and plug in, so let me just start that way I can show you, and plug in Gateway and download the zip file, that gets you a starter project with all your dependencies that are required for Spring Cloud Gateway. All right. So that is what I have sort of exploded in my project over here, with a few modifications that I do. But this is more or less the straight application that I've got from the Spring Initializer. Right. So now, and let me start it up. And before I do this, for the downstream microservice, if I come back to my previous diagram, I don't have these downstream microservices. Right? So what I'll do is I'll use a website called httpbin.org as a sample downstream. This is a pretty cool site if you're just testing your HTTP client. What it does is, let me take a couple of endpoints. So if I just call the get endpoint, it just presents back what you have said, right? As all the HTTP headers. Say if you send some argument to some endpoint, say if I send multiple headers, it would show what those arguments are, right? And similarly for all the other endpoints also, it behaves the same way. So it has a bunch of endpoints, all of them behave the same way. So if you take the cookies endpoint, will show you the cookies. If you do the anything endpoint, will show whatever you have sent, post data, JSON file, right? Then one more that I've used prior, that is the delay endpoint. Say if you want some downstream service to have some delay before it responds to me, I can send it to the delay endpoint with a parameter saying how much you need. Right? So if I say delay/2, this delay by 2 seconds. Right? So very useful if you are developing a gateway-like function, right? So what I'll do is I'll use this site as my downstream microservice for the example, right? Okay, so I have a Spring-based application, a Spring Gateway-based application here. I'll start it up. And you would see that it is Neri-based server that has started, right? At ODB. It's not sort of servlet-based or anything. It's Neri-based. And if I send, say, some request to it, let's do a get, the same request that my HTTP bin site has. Right now, it will say not found because I have not done anything. So increase the size of it. So right now it says 404 because I have not even implemented the BDB at all. Like I'm not intercepting this request and sending it up to 404. Let's now implement that that route, right? So if it receives, my application receives a GET request, then it forwards it to the HTTP, right? And the way to do that is using Spring Cloud Gateway provides a Java-based DSL using which you code those routes, right? So a route will, again, I've put it out here because, okay, so the coding looks something like this. It's a DSL, so hopefully it is readable enough that you can write it yourself, but it looks something like this. So I'll say a route if the if the path matches, say, slash get, if this application receives a request at slash get, then forward it to HTTP bin URI, right? So it's as simple as that. So you can see that it's not sort of complicated at all. All this is saying is when this application receives the request, oh, this is wrong. Slash get, then forward it down, right? So let me just restart the application. That way you can see that now this get will respond. And if I were to make this request now, you would see that this response is from HTTP. So I made a request to my application in turn. My application is forwarded to HTTP and the response is right? And you would see that there are these headers called forwarding hooks and forwarding. These are sort of very typical proxy headers that, because this is behaving like a proxy server here, proxy servers are expected to put in these headers when it makes it upstream. So you would see that those headers are also good. So now let me make a little. So one very common functionality is rewriting paths, right? So say if within your gateway, if you're receiving a request to something else, a very common functionality is to rewrite the path to something else before it meets the downstream call. Right? So let me just show you how easy it looks through this system. What I'll do here is, again, define yet another route. And what this route will do is, and this time, instead of matching on the path, I'll match on a host header, right? Some other header, but not the path itself. So what I'll say is, if the path is something like star.setpath.org, I can now, so earlier I had talked about the predicates, right? So I can add multiple predicates using again another DSL path call. So it's nothing but it's part of the predicate within Java 8, right? So, and that has an operator called AND, where I can say and some other predicate, right? So here, what I'm saying here is, if it is this, if the host matches setpath.org and the path matches some prefix slash the second some other part to it, right? So here I want to capture the segment. That's why I put it to this. Then rewrite the path, right? So the rewriting the path is a filter. So it will look something like this. I'll say set path, and then I'll forward it to the downstream system, right? So what's happening here is when somebody makes a call to my application using /foo/some segment, the downstream system will be called with just the segment part. It will remove the foo. And let me just restart it. So all right, so now the request will look something like this. So I'm making a call to /foo/say get, right? So that is this foo part, and I also have to provide this host, right? So that is a host header with something.setpath.org, right? So what you will see is that when it makes a call to the downstream system, that foo part will get used, right? So it's rewriting the path before it comes to downstream.
Space, so let's start with
So this is a header. This is a post header. And this, it's a syntax of this two terms. Right? That's how you specify the headers for the interaction, right? And then let me just add another header just to show that another header, right? So this is adding sort of two headers to that. So what you would see is that it has made a call to the downstream system without that, right? So it has read it in the path before it calls the downstream system. And you can see that my another header that I've sent has come to. Right? And again, there are all we could all headers. Now let's any questions so far? All right. So now let me add another filter which deliberately adds some header before it makes the downstream call, right? So that will look. Let's use the same example so that. Okay. So what I want to do is I want to add a request header before it makes a downstream call, right? So it looks something like this. So I'll say demo header. So now the expectation would be that you should see this additional header come in the downstream, right? So let me make the same call again. And you should see the demo. Right? So it has enhanced the downstream header with this additional header that I did last time. Right? Sort of one more example that I wanted to show was, are you familiar with Hystrix? Hystrix, Netflix Hystrix, yeah. Hystrix library. It's for circuit breaker, right? Where if a downstream system is taking too much time, you don't want to be connected, right? You want to short circuit that connection to the downstream system, right? So that is a circuit breaker pattern, right? So let me, one sort of good implementation of gateway could be to close the connection to a downstream service if the downstream service misbehaves, right? So let me show you how that code looks. And you know what? I'll code it again as part of this itself. So I'm adding Hystrix I'm adding a filter which implements Hystrix. And the one parameter that you have to give here is, so if you're familiar with Hystrix, you have to give something called a command name. Maybe so Hystrix, so you configure Hystrix using a command, right? So you attach configuration to that command name, right? That's how you tell, say, by default, the downstream systems typically have a timeout of 1 second, which is good enough for a company like Netflix because their services are super performant, right? But for normal companies, 1 second probably is too low, right? So you may want to increase that 1 second to say 3 seconds or something for companies like, say, where I work, right? So you do that by attaching properties to the command, right? And I'll show you how it is done. So for now, I'm just calling it, I'll just call it some command. Right? And let me show you the behavior now. So for this example, I'll call, or you know what, let me just copy the example from here. All right, I've modified it a little. So I've defined a brand new route like this. Let me. Okay, so what this means is, if I were to make a call with a host header of something called Hystrix.com, it's going to make a call through this Hystrix. And I'll demonstrate it using that delay endpoint that I had shown before. So now if I were to make a call to something.hystrix.org with, say, a delay of 1 second, right? So I'm sending a request to my system with a delay of 1 second. Send a request to downstream system with a delay of 1 second, right? And what will happen is, it's happening, right? Let's see what happened. because I have, so this is the way that you configure this. So here I have set a timeout. That's why I want to do timeout. So let me put it back to 1 second. So if I were to make this request now, it should time. Say, I'll just come back to the file. So now the way to increase the timeout is using, so this is where I attach properties to this some command. Right? So here what I'm saying is increase the timeout to some number, some other number. Don't put a default of 1 second, put something. Right? So I'll increase it to say 3 seconds. And if I were to make the call now, the 1 second one should go through, right? But anything more than 3 seconds should break. So I'll just put it at 3, which is right around the border. So it should ideally give a timeout. Right? So you can see how easy it is to implement a circuit breaker right within the gateway using a very simple, very, very small amount of code, right? This would have been super difficult using something like that's all I had actually, right? So can
you mess with the payload?
You can, but it's not advisable because it's a sort of streaming data. To get to the payload, you have to buffer somewhere, right? And that is not advisable for the non-blocking. The expectation is that you should just sort of just deal in streams, right? So if you really want to do that, a better you can, but it's definitely not advised. If you really want to do that, it may be better to put another service out there which does that kind of thing, right? So, but it may not fit into gateways.
But you could do it in a streaming way.
So typically, if you want to transform, yeah, if you can transform in a streaming way, yes, that will work, right? But if you need to buffer, if you need to see the entire body before transforming, then it may not be advised, right? Yeah, but you're right. If you can do it, if you can sort of deal in streams and modify the streams directly, then yeah, you can. It'll probably work.
So I'm curious, like, I mean, I'm a Java developer. I want to use this, but like my DevOps people would probably say like, do that in Nginx.
Okay.
Or something that's more familiar to like that skill sets in that group.
That's so.
Are you seeing that too, or is there like compelling arguments to make to use this?
So exactly the point that you mentioned, which is Nginx is not accessible to a Java developer, right? So say Nginx works off configuration, I'm guessing, right? Configuration and plugins. And if you want to write plugins, you have to probably write C++ code and stuff like that, right? So if you want to do anything out of the comfort zone of Nginx, you'll probably have to code, right? And then the coding is unfortunately C++ at that point, which as a Java developer, at least I wouldn't be able to do, right? So this is, I would say, accessible to Java developers, right? So if you as a Java developer, if you're tasked with writing a gateway, then either Zool or Spring Cloud Gateway could be a good fit, right?
Second, that it's not just familiarity from the Java perspective, but this version is just automatic.
Correct. Yeah, you just throwing configuration out there without having traceability. Yeah. Any other questions? All right. So the very last thing is my coordinates, right? So if you have any questions after this, you can get in touch with me. I'll circulate this deck also with the meetup link. So at the very bottom of the link, I'll post this deck also, and that has my coordinates, which is this. Again, I don't think anybody will be listening, but I'll circulate it out. But yeah, feel free to get in touch via email or even via Twitter, and you can continue the discussions there.